Hello again to the friends and companions of the Romak Tech channel. Thank you for choosing this channel as astronomy training. Before everything, thanks for subscribing to like and comment. Astrophysics. Astrophysics is the branch of astronomy that employs the principles of physics and chemistry to ascertain the nature of the astronomical objects, rather than their positions or motions in space. Among the objects studied are the Sun, other stars, galaxies, extrasolar planets, the interstellar medium, and the cosmic microwave background. Their emissions are examined across all parts of the electromagnetic spectrum, and the properties examined include luminosity, density, temperature, and chemical composition. Because astrophysics is a very broad subject, astrophysicists typically apply many disciplines of physics, including mechanics, electromagnetism, statistical mechanics, thermodynamics, quantum mechanics, relativity, nuclear and particle physics, and atomic and molecular physics. In practice, modern astronomical research often involves a substantial amount of work in the realms of theoretical and observational physics. Some areas of study for astrophysicists include their attempts to determine the properties of dark matter, dark energy, and black holes, whether or not time travel is possible, wormholes can form, or the multiverse exists, and the origin and ultimate fate of the universe. Topics also studied by theoretical astrophysicists include solar system formation and evolution, stellar dynamics and evolution, galaxy formation and evolution, magnetohydrodynamics, large-scale structure of matter in the universe, origin of cosmic rays, general relativity and physical cosmology, including string cosmology and astroparticle physics. Astrochemistry. Astrochemistry is the study of the abundance and reactions of molecules in the universe, and their interaction with radiation. The discipline is an overlap of astronomy and chemistry. The word astrochemistry may be applied to both the solar system and the interstellar medium. The study of the abundance of elements and isotope ratios in solar system objects, such as meteorites, is also called cosmochemistry, while the study of interstellar atoms and molecules and their interaction with radiation is sometimes called molecular astrophysics. The formation, atomic, and chemical composition, evolution, and fate of molecular gas clouds are of special interest because it is from these clouds that solar systems form. Studies in this field contribute to the understanding of the formation of the solar system, Earth's origin, and geology, abiogenesis, and the origin of climate and oceans. Astrobiology. Astrobiology is an interdisciplinary scientific field concerned with the origins, early evolution, distribution, and future of life in the universe. Astrobiology considers the question of whether extraterrestrial life exists, and how humans can detect it if it does. The term exobiology is similar. Astrobiology makes use of molecular biology, biophysics, biochemistry, chemistry, astronomy, physical cosmology, exoplanetology, and geology to investigate the possibility of life on other worlds and help recognize biospheres that might be different from that on Earth. The origin and early evolution of life are an inseparable part of the discipline of astrobiology. Astrobiology concerns itself with the interpretation of existing scientific data, and although speculation is entertained to give context, astrobiology concerns itself primarily with hypotheses that fit firmly into existing scientific theories. This interdisciplinary field encompasses research on the origin of planetary systems, origins of organic compounds in space, rock-water-carbon interactions, abiogenesis on Earth, planetary habitability, research on biosignatures for life detection, and studies on the potential for life to adapt to challenges on Earth and in outer space. Physical cosmology. Cosmology, world, universe, logos, word, the study, or literally logic could be considered the study of the universe as a whole. Hubble extreme deep field. Observations of the large-scale structure of the universe, a branch known as physical cosmology, have provided a deep understanding of the formation and evolution of the cosmos. Fundamental to modern cosmology is the well-accepted theory of the Big Bang, wherein our universe began at a single point in time, and thereafter expanded over the course of 13.8 billion years to its present condition. The concept of the Big Bang can be traced back to the discovery of microwave background radiation in 1965. In the course of this expansion, the universe underwent several evolutionary stages. In the very early moments, it is theorized that the universe experienced a very rapid cosmic inflation, which homogenized the starting conditions. Thereafter, nucleosynthesis produced the elemental abundance of the early universe. See also Nucleocosmocrinology. When the first neutral atoms formed from a sea of primordial ions, space became transparent to radiation, releasing the energy viewed today as microwave background radiation. The expanding universe then underwent a dark age due to the lack of stellar energy sources. A hierarchical structure of matter began to form from minute variations in the mass density of space. Matter accumulated in the densest regions, forming clouds of gas and the earliest stars, the population 3 stars. These massive stars triggered the ionization process and are believed to have created many of the heavy elements in the early universe, which, through nuclear decay, create lighter elements, allowing the cycle of nucleosynthesis to continue. Gravitational aggregations are clustered into filaments, leaving voids in the gaps. Gradually, organizations of gas and dust merged to form the first primitive galaxies. Over time, these pulled in more matter and were often organized into groups and clusters of galaxies, then into larger-scale superclusters. Various fields of physics are crucial to studying the universe. Interdisciplinary studies involve the fields of quantum mechanics, particle physics, plasma physics, condensed matter physics, statistical mechanics, optics, and nuclear physics. Fundamental to the structure of the universe is the existence of dark matter and dark energy. These are now thought to be its dominant components, forming 96% of the mass of the universe. For this reason, much effort is expended in trying to understand the physics of these extragalactic astronomy. The study of objects outside our galaxy is a branch of astronomy concerned with the formation and evolution of galaxies, their morphology, description, and classification, the observation of active galaxies, and at a larger scale, the groups and clusters of galaxies. Finally, the latter is important for the understanding of the large-scale structure of the cosmos. Most galaxies are organized into distinct shapes that allow for classification schemes. They are commonly divided into spiral, elliptical and irregular galaxies. As the name suggests, an elliptical galaxy has the cross-sectional shape of an ellipse. The stars move along random orbits with no preferred direction. These galaxies contain little or no interstellar dust, few star-forming regions, and older stars. Elliptical galaxies are more commonly found at the core of galactic clusters and may have been formed through mergers of large galaxies. A spiral galaxy is organized into a flat, rotating disk, usually with a prominent bulge or bar at the center, and trailing bright arms that spiral outward. The arms are dusty regions of star formation within which massive young stars produce a blue tint. Spiral galaxies are typically surrounded by a halo of older stars. Both the Milky Way and one of our nearest galaxy neighbors, the Andromeda Galaxy, are spiral galaxies. Irregular galaxies are chaotic in appearance and are neither spiral nor elliptical. About a quarter of all galaxies are irregular, and the peculiar shapes of such galaxies may be the result of gravitational interaction. An active galaxy is a formation that emits a significant amount of its energy from a source other than its stars, dust, and gas. It is powered by a compact region at the core, thought to be a supermassive black hole that is emitting radiation from infalling material. A radio galaxy is an active galaxy that is very luminous in the radio portion of the spectrum and is emitting immense plumes or lobes of gas. Active galaxies that emit shorter frequency, high-energy radiation include Seyfert galaxies, quasars, and blazars. Quasars are believed to be the most consistently luminous objects in the known universe. The large-scale structure of the cosmos is represented by groups and clusters of galaxies. This structure is organized into a hierarchy of groupings, with the largest being the superclusters. The collective matter is formed into filaments and walls, leaving large voids be. Thank you very much for being with us until the end of the video. Please do not forget to subscribe, comment, and like. So that is another educational video. God is with you.